is my pleasure to introduce to you Ted Zolly. He is an engineer and the project manager for the design team at HNTB, who SDOT has hired to design a replacement project. I do want to remind everyone that we haven't hit that repair or replacement decision yet, but in order to keep everything moving at top speed, we are pursuing replacement design. Ted, if you want to say a little bit more about yourself, just to orient folks to your experience, that would be great. And over to you.
Sure. Thanks, Heather. Yeah. So just a very little bit about me. I'm a structural engineer, bridge engineer by trade. I've been doing this for 30 years or so, and often get involved in emergency projects and emergency replacement projects. So this is, even though I know it's incredibly disruptive, these sorts of projects are eerily similar to other projects I've done that I'll walk you through. So maybe with that, we start with, if the next slide, we start with a little bit the sensibilities we have about emergency replacements. And this bridge in the right-hand image is the Lake Champlain Bridge. And this was a bridge that had an emergency closure, and it didn't carry much traffic, but the detour was almost 100 miles in the wintertime. So these two communities on either side of the lake, there were farmers that had fields on both sides that they couldn't harvest, shared hospitals and fire departments. It was very, very disruptive. And from this project, very particularly, I learned a lot about how to look at speed and safety as really the principal important mechanisms in terms of designing replacement alternatives. So really, when we think about West Seattle at HNTB, we think speed is absolutely first and foremost, but safety and durability go along with it. And so a lot of our thought process around a bridge that looks somewhat like Lake Champlain, but recognizing the very different circumstances we have at West Seattle, are really focused on speed. One other thing that I would mention is that online replacements, as opposed to offline, are usually the right decision if you're trying to streamline a project. And so we really see that online replacement is the only viable option if speed is our top priority. The other decision we made in terms of developing this concept was that we would reuse the existing substructures and foundations. And that does a couple of things. One is it reduces costs and streamlines the permitting process, and those are incredibly important. But it's also that we see great value in the replacement strategy that we've developed by reducing mass and using seismic isolation to maximize the seismic performance of the existing substructures. So there's a lot to work with the existing foundations and piers, and we want to take deep advantage of that. Now, obviously, the Duwamish, this west branch is incredibly important in terms of navigation. This is a much, as busy a navigation channel as there is. We've done many emergency projects with heavy navigation, and this bridge opening, the swing bridge opening 1,800 times per year is a testament to how busy this is. So we recognize that. Seismic performance, I like to think that the Pacific Northwest and the Seattle area has an earthquake every 20 years or so. And so we're about due. Obviously, seismic performance is crucial, and it's been at the forefront of the way we think about replacement. A little bit more about, for us, this use of heavy lift techniques and engineered demolition. We like to think that if you haven't thought about the construction strategy, you haven't designed the bridge to be built quickly. And so every move we make in terms of replacement options has with it a construction strategy. And for West Seattle, it's no different. And then coming back to Lake Champlain, what we were able to achieve with Lake Champlain was a replacement, an online replacement, where it was about 2,000 feet of bridge as opposed to more like 1,300 we have at West Seattle. And all the substructures were replaced in this particular project. And that was all done in an 18-month time frame. So that really demonstrates that we can do these projects very quickly. You can go to the next slide. So this is a video that will talk through at least conceptually the way we see the demolition and reconstruction, how that happens. So you can play. So as we're building on alignment, and hopefully this video comes through clearly, the first thing we do is we demolish the damaged portion of the West Seattle Bridge, and we do that with a heavy lift technique. Subsequent to that, we can take the bridge apart piece by piece, similar to the way that it was built. And now we're going to reduce the pier height some and replace and connect the two pier shafts with a cap. This allows us to stick build a steel superstructure, and then this gets us ready for float-in operations. The big advantage here is the approaches and the arches can be built at different fabrication shops independent of each other. And here you can see that we have two arches, twin arches, and they're delivered and lifted independent of each other, and perhaps could be open to traffic independent of each other. This strategy of the heavy lift technique allows us to follow the navigation channel the minimum extent possible, less than 24 hours, and that's both for demolition of the existing and replacement of the new spans. So the big advantage here that I want to get across is while we're demolishing the existing West Seattle Bridge, we're fabricating the new West Seattle Bridge and designing the new West Seattle Bridge. So the fact that we're doing parallel activities is what saves schedule. The same is true for fabrication. The fact that we can fabricate the approach spans independent of the arch spans, this is what saves schedule. So simultaneous parallel activities is the strategy for speed. Next slide. So a bit more about seismic and some of what the risks that we see here. First of all, demolishing the existing West Seattle Bridge, given that it's damaged and compromised, represents some significant risks. And so in terms of the heavy lift strategy that we've identified, we feel that we can lower the damaged portion in its entirety rather than putting construction equipment back on the existing span. And that for us, I think safety is the most important thing, but the demolition will be very much
after this meeting.
Will be very much an engineered construction. There's no explosive demolition or anything like that. This is engineered, and heavy lift techniques are, we think, the right strategy. The next would be seismic performance, and one of the challenges with the Duwamish and really this part of Seattle is the potential for soil movement, liquefaction and lateral spreading, and even down drag and settlement of the foundations. So one of the strategies of this alternative, this rapid span replacement, is to introduce seismic isolation to reduce the demands on the existing substructures, and also to allow for displacement, whether that's vertical or horizontal in any direction. The beauty of a bridge like this that includes a network arch and the approach spans is that we can tolerate displacement. So we're reducing the seismic demands or the seismic performance that the existing piers need to provide in order to provide a bridge that meets a critical designation in terms of seismic performance. Other risks are clearly permitting and lead agency identification, so building on alignment and staying out of the water. These are strategies that minimize those risks, and we're working through those. Obviously, identifying funding and making sure that funding is in place to support construction is a challenge and a risk. And probably the one that on the engineering side we think about as crucial is how constrained the site is. There's very few bridges, I can think of none, where the swing bridge opens underneath the span we're trying to replace. It's a very constrained, very busy site, and I think the barge logistics and how we do these heavy float in, float out operations will very much influence the way we design both the arch span and the way we design the demolition. So the next slide. Um, so a bit about safety and durability. Obviously, these are also clear goals. So the this structural system may seem a little unusual. So obviously, these delta frames, this approach that has the blue circle around it, what that allows you to do is to project, so reduce the length of the arch span. So we see the arches as being 450 feet span or less. And so what this strategy of introducing these delta frames, it allows all the superstructure system for the approaches to be redundant, so extra safe. You can think of it that way. And the same with the network arch. This use of crossed cables. All of these components are designed to be redundant and replaceable under live load. So one of the things that you can imagine about the existing West Seattle Bridge is you're closing it to live load to make repairs. The way these network arches are designed and the approaches is you can repair the components that are potentially damaged, like the deck and the stay cables, while you're operating under live load. I've spoken about enhanced seismic performance, and we're doing that both through isolation bearings and through a much lighter structure. So the structure weighs about 40% less than the existing West Seattle Bridge. In terms of durability and steel, steel is maybe not as recognizable a material to the Seattle area, and we've made a lot of headway with better coatings. So we're proposing to use metallizing or thermal spray coatings, which double the life over paint. We are designing everything for 100-year service life, for larger live loads, and replaceable components, and again, much more tolerance to seismic movements, and also a better understanding of, should we have movements, what's our condition assessment of the bridge. So one of the big advantages about displacement tolerance is we can see how much displacement we were subjected to in a seismic event and make a go, no-go decision live. So we're not waiting for instrumentation or engineering. We know live whether we can reopen the bridge directly to emergency vehicles or regular traffic. Next slide. So obviously permitting is a key to any replacement project, and so our goal here is to eliminate in-water work, especially for new construction. Obviously, for float-in, float-out operations, we're in the water, but we're keeping navigational channel closures to less than 24 hours. This minimizes fisheries impacts, any hazardous material within the Duwamish. We're bordered by Superfund sites. We feel with the seismic performance, we can minimize or potentially eliminate foundation strengthening, and all of that leads to faster permitting, with potentially the Coast Guard as the lead agency. The next slide. And then finally, obviously, to circle back to the beginning, the goal here is for speed, right? So what our intent is to get a replacement option that's on a par or very close to the time it takes for rehabilitation. And so in order to do that, we see these parallel activities with demolition and design and fabrication happening simultaneously. So while we're demolishing, we are building the replacement structure. Our goal here is to have the new bridge opened in the first quarter of 2023. That would be the target. And we feel that's feasible given a fast track start and moving very quickly. And then in terms of service life, we feel that 100 years is a very reasonable target, and so we should be designing the superstructure for a 100-year service life. And with that, I think we feel comfortable that given our experience with Lake Champlain and how rapidly we were able to do that project, with some very positive outreach we've had both to Northwest fabricators and erectors. It's a great time, given what we're going through with COVID, to put a project out on the street, both in terms of fabricator availability and the the major contractors who do this sort of heavy lift work. It's a great time to do a project like this. So we expect to get competitive prices and a lot of interest in the project. And so we feel that there's some advantages, obviously, to rapid replacement, and a lot of those advantages stem around delivering this very quickly and on parallel tracks. With that, I think that's my last slide, and I hope I've left plenty of time for questions and answers, as I'm sure there are many, and you'll appreciate that we're in early phases in this, but I'm happy to answer any questions I can.
Let me, we're going to have, as you said, lots of questions. Let me ask three fairly quick ones. The scale of this project compared with the one that you had at Lake Champlain. Mm-hmm.
Yeah, let me answer that quickly. So Lake Champlain was an $80 million project delivered in about the 2010, 2011 timeframe, Greg, and it was, in terms of square footage of bridge, it's a narrower bridge, but in terms of overall square footage, it's on a par. Now, obviously, this is a much more constrained project, and the arches, this is about the same span as Lake Champlain in terms of the arch span. And it's about the same width, but we have two of them, if that makes sense. So we have two Lake Champlains next to each other in terms of comparisons.
Okay. Second, the clearance over the channel. Is it equivalent to the current bridge? Is it flexible if the Coast Guard were to say, no, we'd like it to be 10 feet or 20 feet higher?
So it's a great question. So obviously, one of the advantages of the shallow depth of the arch is that we can enhance navigational clearances. So with the current posted speed, which sets the vertical curve, and the shallow depth, we can easily gain 10 feet of additional clearance. So that gets you from 140 feet to 150 feet, and perhaps widen the channel some too, because as you know, the existing bridge has the haunches, which makes it deeper. And the channel is, the bridge is very skewed to the channel. So there are navigation enhancements possible without changing the approach grades. Okay. And they're on the order of 10 feet.
Last question. In my public career, working on light rail and all kinds of projects, capital projects, I was taught you can have it cheap, you can have it fast, you can have it good. But you can't have all three. You can only really realistically get two of those. Which one is this vulnerable to?
You know, how would you say? I think we haven't done our job unless we give you all three. And, you know, I think, look, if you were to rank them hierarchically, I think speed has to be first, right? And I think we really can't compromise on safety and durability. I think one thing to think about is just how difficult this corridor is for bridge replacement. And it's the challenge we have in front of us, right? And so I think we can't really compromise on durability, and by that I connect safety, because this is an enormously difficult site. This is not something where we want to do this again anytime in the near future. And also my experience in urban environments is it only gets worse over time, right? So if we imagine, in the 80s when the existing bridge was built, we didn't have a lot of the constraints we have now. If we imagine 10, 15, 30 years into the future, those constraints are only going to be more difficult. So I think we owe you a very durable, very safe bridge, because that's what you need in this crossing. And so this is not a place for compromising, frankly, Greg, in my view.
All right, thank you.
Questions, and I would just add the one more that I had been meaning to ask you, Ted, about. I would like you to respond to the environmental impact to a river that has already been getting a lot of abuse. I'm sure you have already.
Yeah, right, yeah. And so very clearly, right, given that, we're really bounded by Superfund sites. So this particular crossing, in terms of operating units, isn't within an operating unit, but obviously there's lots of reasons to stay out of the water. most of them having to do with environmental impacts. Generally speaking, a lot of the damage we do in bridge construction, in heavy civil construction, has to do with in-water impacts. And so our goal here really, Pauline, is to stay out of the water. Staying out of the water reduces those impacts to the extent possible. That doesn't mean we're going to have, obviously, construction activities and lay down areas and equipment, but a lot of that can happen with this alternative in the existing alignment, if that makes sense, so that we can keep even the on-land footprint low. And obviously that is our goal, and that's a strategy to let's say reduce the permitting risks we may have, and obviously reducing environmental impacts enhances your permitting capability. So we really feel like staying out of the water is essential. And if you think about even building a new bridge on alignment, we don't think you could build a new bridge with the piers that are so close to the shoreline or even partially in the water. So one thing I would also think about is in a full replacement where we were not reusing the existing substructures, we'd have to significantly increase the span just to stay out of the water, is my guess. So it just highlights, Paulina, the value of staying out of the water in terms of permitting.
I have Jen Temple next, followed by Ann Higuera.
Thank you very much for that presentation. Two questions. In the timeline, I'm not seeing the securing funding or permitting, taken into account. So how does that play out? This, if we were to have this as an option, opening in the first quarter of 2023, we would have to have funding in place in 3 months?
Yes, so these are great questions, and so there's a lot to think about. So let's talk about funding some. So the two work activities that take the first year or so are demolition and fabrication. And so in terms of costs, those are actually relatively small costs in the context of the larger project. So you already have, in my view, the city's done a remarkable job at putting funding together already just for the the rehabilitation option. And some of that funding, if we were to move to a replacement option, could go to those work activities, demolition and fabrication. Those are what I'll call relatively small dollars. So there's not big outlays associated with, we'll say, the first year and a half of construction. Where once you've taken delivery of the steel and erected it, that's where the big dollars come in. And so then you don't have to be so compressed in terms of time frame to think about what activities you may do. I think you could proceed with demolition and fabrication on separate tracks and not have the full funding for the project in place. Then in terms of permitting, it depends on if we permit demolition as a separate activity from bridge reconstruction. It depends in a way how those contracts are packaged. But our hope here is that we can use streamlining in terms of permitting and use a categorical exclusion or even a nationwide permit could be used potentially for demolition. So there's some streamlining that you get out of staying out of the water and building on alignment and replacing the superstructure only that we feel we can take advantage of. They're both really good questions.
One of the risks, though, still is we could get a year in and not have funding to continue.
Yeah, so clearly, in terms of how we string together funding, and we do have a group that's going to be focused on that. And our goal, obviously, would be to have the project fully funded before we start. But the question is before we start what, right? So there can be these, we'll call them nuances, but they're important because it depends on which funding instrument and what we're funding that dictate what the schedule may be. my sense that with emergency projects and I think the the proof will. I mean, the truth will tell. But with this significant a bridge out of service for West Seattle, I just can't see that funding of only the replacement of the superstructure will be a barrier to getting this done on time. I just think there's too much demand for this structure being restored that funding, it may be complex funding. It may have many.
Ted, Jen, that's all true, Ted, and I appreciate it. And we're looking forward to working with the folks at HNTB who have that funding and financing expertise. Jen, I think it's a worthwhile conversation to have, because not just for this particular option, but for any option, including repair, we're going to need financing help. And so I think for a future meeting, it's probably worthwhile to have a conversation specifically about our funding strategy, which is, we're still putting the finishing touches on it, but it is multifaceted, and we are not relying on any one source for all the money. So,
and I can tell you, these mega projects rarely have 100% of the funding in place. You need to sort of walk up to the edge and take a little bit of a jump. And that was true with the viaduct, that was true with Sound Transit, that was true with Mercer Street, and it was true with the West Seattle Viaduct. We needed to move forward. They were necessary. We had a plausible financial plan, but we didn't have 100% in the bank. So that's going to be true with this one, I have no doubt. And that will mean some sleepless nights for Heather and others. But as long as you've got a reasonable plan and some backups in case pieces don't happen the way you expect, that's kind of how these projects get put together.
That's right. And having lived through all of those projects with Mayor Nichols, we've learned some lessons from all of those approaches. So we every time we get a little bit better. Sorry, Ted.
No, you said it much more elegantly than I did. So thank you.
And to be followed by Dan.
Hi, this is Ann Higuera. I'm with Fentana Construction, West Seattle business owner. My question is about the structural integrity of the piers that you're proposing to put the span on top of. So in the CBA, and I admit I've not read the entire thing, and I know it's not your document, but something that caught my eye was that Alternative 4 required future retrofitting of Piers 16 and 17. It didn't say when that would happen, but it said that it was something that would be required. And it made me wonder about whether that has been taken into account with the early thoughts about the rapid span replacement.
Yeah, so it's a great question and completely fair. So what our strategy has been is to reduce if you think about the reason that we would need to repair or strengthen the existing pier and substructures, it would be primarily because of seismic. So in order for us to get, let's say, as little strengthening as possible, the strategy here has been to make the bridge much lighter, so less mass, less force demands, and then to seismically isolate it, which is another technique which basically allows you to take out energy from the superstructure before it gets to the substructure. So really our goal would be in terms of our target, would be not to have to strengthen neither the piers nor the foundations for the main piers. The only other thing I would say is that it's one aspect of the original design that leaves us in a really good place, in a sense. The piers were very robustly designed with good seismic detailing, as were the foundations. And our initial look at the foundations is they have enhanced capacity over what we would have, the capacity we would have given them in the 1980s when they were designed. So there's some positive news there. And then the other, just to give you context, the piers on these piers to support the same bridge are about twice the size as the piers on Lake Champlain. So one aspect of this that gives me a lot of hope is that is how robust and how enormous these piers are, how much we have to work with, because we are supporting a much lighter bridge, and a bridge that will deliver much less seismic force to the substructures and foundations. We think there's a lot of positive news there. Can I say that we won't need any strengthening? It's too early to tell that.
Dan Austin, to be followed by Peter Steinbrook.
Hi, Dan Austin with the West Seattle Chamber again. I just wanted to ask a question. I'm not sure if this is going to be asked out of the presenter to answer here, but two concerns I have. Whenever I hear fast tracking of EIS in the city of Seattle, thoughts of lawsuit alarms ensuing go off loudly. Throw in tribal land being involved. Have we spoken with the tribes on how they feel about a streamlined process of an environmental study? Heather, I see you there. Second question is, will we also see a risk analysis that's apples to apples or same style that we received on the other alternatives we have in the CBA? And when can we expect to see that? So I'm not sure who that goes to, but thank you.
Can I speak about the tribes? So we have conversations with tribal members set up, and specifically are going to introduce this concept to the Muckleshoot later this week. In my experience, and I want to make very clear that we are on Coast Salish land, and we respect that above all, not least of which because those treaties are indeed federal law. So no getting around that, even if we wanted to. My experience, though, tells me that their primary concern has to do with access to the river for their fisheries. And Ted, I'm not sure if you mentioned this, but those bringing those barge pieces in and out are we can create those windows that meet everybody's needs. I also think staying out of the water is going to be key to making sure we're not running afoul of any of the tribal interests and the law.
Very good. Commissioner Steinbrook?
Thank you, Mayor Nichols. This is a really fascinating and lucid presentation. I found the visualization to be dazzling, in fact, and that bridge, that double span bridge, looks very appealing. I'd like to see consideration of mass timber hybrid construction in it for sustainability. But my questions really have to do with the serious lack of confidence that I have in the permitting and funding risk side of this. And that's been touched upon a little bit here, but with a 2023 delivery, well, I do believe miracles can happen if there's a will and a determination, but they're very rare, particularly with regard to Seattle process and all the stakeholders. Mayor Nichols knows that all too well. But so those are my greatest concerns here. But I also wanted to ask about the projected duration and number of duration of shutdown of the lower bridge that would be necessary during demolition and erection, and if it would be once or repeated shutdowns on the lower bridge, because that would be the most serious impact imaginable, to have the lower bridge shut down for any period of time. You mentioned 24 hours, but I can't believe that would be the entirety. Also, the visualization really should represent the lower bridge, which it did not. So, in the bird's eyes.
Yes, so the lower bridge, in terms of its open, so these are all great questions. So let me speak to the we'll call it the float in, float out logistics. So clearly the site is so constrained that the lower bridge must open to deliver, so anything that's this big would come from Elliott Bay side of things, right? So in terms of the navigation channel, we'll call it fouling. The swing bridge has to open and then close in order for you to, and then the barge is positioned in order to deliver the span or to remove the existing bridge. And so those operations, in terms of, we'll call it the outage of, so it would be navigational closure, Peter, for your interest. So we're talking about a channel shutdown of 24 hours at the outside. Typically, Lake Champlain, for example, was erected in 12. Not as busy a navigation channel, but 24 would be an outside, meaning we should be able to lift or lower in a 12-hour period. But we typically get 24-hour channel outages should something go wrong. Those outages would be one-time outages for each lift or lower. So the plan would very likely be we split the existing bridge in half and do 2 lowers, and the same would be true for the arch installation. So you're talking about a total of 4 24-hour channel closures, staggered and obviously coordinated with navigation traffic. Yeah, and on the miracle side of things, I how would you say? I think this is where I guess we need to be able to do these sorts of projects. That I just don't buy that we can't figure out how to replace bridges quickly when we need to. So I just can't think of a project in the country that's more worthy of a fast track replacement than this bridge. So maybe it takes some miracles, and what I found in permitting, and especially for Lake Champlain, and it's a great example, is the permit agencies were very aligned, and the resource agencies, and we had 2 states, so we had state of Vermont and state of New York. They really came to the table and helped us find a way to do this rapidly. Yeah. So I think permit agencies really understand the hurt that people are feeling and the need to get this bridge replaced. So I feel like the permitting side will get there. The funding is hard, but I really appreciate that sentiment and optimism and can-do attitude. I think we need that.
Well, I'm sorry, Commissioner Steinbrook, can I just say that it's Ted's can-do attitude is amazing. Yeah. And I have a can-do attitude, but what we're going to need is a can-do attitude on the part of elected officials who are in control of money that is going to be needed in order to complete this bridge.
And there's an environmental component to this also.
I'm just saying that everyone's going to have to come together with a can-do attitude on this one.
But you can't speed up the SEPA process, though, and I imagine it would be required for replacement and demolition replacement. SEPA.
So we did NEPA SEPA on Champlain in 6 weeks, to give you context.
I've heard of that.
Thank you. Thank you. Let's move on to the next. I think we have
Dan Austin. Councilmember Herbold after Dan.
Sorry, this will be really quick. I just needed an answer to the second question I had asked in the first place. If when we were going to have a risk analysis that's more comparable to the CBA that we're currently looking at on this new bridge option with the risk assessment. Is that something that's on its way?
Are you asking for like a CBA type analysis to put this idea next to the other ideas that we've discussed?
Well, I mean, are we calling this Alt 4 with new build technique? And if that's the case,
this is Alt 4. The CBA had one version of Alt 4. What they looked at is both a concrete segmental box girder bridge idea, and then also a steel box girder. This is just another version of superstructure replacement. And I think, it's hard because the CBA, it requires us to pick something to cost out, right? And it requires us to select numbers so that we can do the arithmetic. But fundamentally, and I think this is important for our next conversation, fundamentally, the cost benefit analysis is not about which version of superstructure replacement we select, or which version of repair, or which version of replacement. It's about sort of a representative example, like an archetype. And so as we move forward, if the mayor decides that we're going to move forward on the repair track, and we begin the 12-week type, size, and location study, that's when we're going to get into some more of those detailed questions about, concrete, steel, this kind, that kind, network arch, box girder. Ted is bringing us a compelling idea. We're not deciding that that's what we're going to do, right? That's where the type, size, and location study comes in, where we get into those more details.
Okay. I think there's the little concern I have is that the public-wise, this is now sounding like the leading option for replacement. Maybe it's not supposed to be, but it definitely sounds that way, and we're supposed to make a recommendation to the mayor between repair and replace on a possible 3-year superstructure replacement that we don't know if we can do or it's what we're even gonna do. Makes it really hard to make that decision, that recommendation to the mayor. That's my big concern. But it is what it is.
It's a hard job.
This is an intriguing option, and I'm very happy it's come forward. It has to be vetted, as any option is going to have to be completely vetted. Let's go to Councilmember Herbold and then Diane Sosnick.
I believe my question may have just been answered by Heather when you said that this option is, in essence, the Alt-4 option. Does that relate to the cost estimate as well?
Ted hasn't done cost estimation for that, but I think it's probably in that same neighborhood. The chief difference, other than form factor, is that Ted and the HNTB team believe, and SDOT is becoming increasingly intrigued by the idea that they could do this faster than the option that was considered in the cost benefit analysis. So, and that has a material impact on a number of the attributes. So, which you'll hear about in the next presentation.
Yeah, Lisa, maybe what I would say is that one of the let's say if we look at the alternative 4s, where does this fit within the context of the other alternative 4s? What our target was much faster, and so the way we got to much faster, and these are qualitative, not quantitative observations, but the problem with the other Alt-4 options is that you can't do them in parallel activities. So if you think about the concrete box, you can't start building the new concrete box till the old concrete box is gone, right? So that's that's a series versus a parallel decision. Even with the steel box, the problem with the steel box is you could be fabricating it, but it needs to all be fabricated in one shop because every piece has to fit precisely together. So you get at least the logic behind why we feel that this is rapid and what the strategy is around replacing this quickly. And again, I mean, that was our stated goal because we see that that's really the necessary problem to fit. The primary problem to fix is restoration of traffic. That really is the job one here.
Diane Sosnick, to be followed by Sam Zimbabwe.
Thank you, Mayor Nichols, and thank you, Ted, for that really interesting presentation. I'm with the Service Employees International Union, and we represent healthcare workers and essential workers who live over here and are, dependent, obviously, in getting back and forth easily. I would say in general to the whole group, but I don't see it a question of miracles. So, I sort of want to take that word out of the equation. I think this is about political will and speaking with one voice as much as we can, because, you know, I know I'm a relatively newcomer to this committee, but I know there have been, what I've heard and seen has been numerous discussion meetings and materials produced. And, you know, our organization worldview is you make things happen quickly by doing. You know, you have to do your due diligence, but at some point, we have to move. And, you know, I think that you have hit in your presentation many of the boxes and questions that have been discussed and rightfully so, you know, needed to deliberation. One question that I have in terms, and this relates to basically political will and making things happen, has to do what I've heard a number of times reported over the last so many meetings, that is it the Coast Guard that has to do some of the permitting or approval process. And I'm a nurse, so I know nothing about construction. I know how to help people get well and, you know, hopefully protect from COVID. But it's like, I don't understand why we can't just make as part of this plan, like you said, you had 6 weeks or whatever for a certain type of permitting, that these are people who, they're not elected, they're hired for their positions, they're accountable to, I don't know, a new administration, you know, federally, you know, where does their authority come from? And that we have to be, it's incumbent upon us to build that into the process, the expectations and timelines that don't just go with status quo, but say there's a new imperative here. And I like the kinds of things you were saying and what we could learn from that in New York and Vermont. I had asked the staff a question earlier, and it's a different country, so I know things around decision making and permitting is different, but I was wondering also if there's anything from the Genoa, Italy bridge repair, and I know different, it fell and people were killed and so forth, but is there anything from that that helps inform any of these potential stumbling blocks? Thank you.
You know, if I'll take a shot at that, but Heather and others join in. You know, what I would say is that first and foremost, the Coast Guard is a very professional organization and has a responsibility to navigable waterways. So this is not something that, in my world, this is part of the air we breathe. So we're always working with the Coast Guard to make sure that the navigable channels, and obviously the Duwamish is incredibly important, right? I think if you look not just regionally, but even Alaska, and just how much shipping, you know, 2,000 openings for that swing bridge a year gives you a sense of just how much goods and services are coming through the Duwamish. So the Coast Guard has every need and imperative to make sure that navigation continues and that we're not impeding that navigation in any way. So, you know, I think we see them as partners. I don't believe that there are lots of stumbling blocks here. You all know that the permitting process, generally speaking, is time consuming. You've lived through some of that with, I'm sure, Alaska Way and other projects. But my experience on emergency projects is we can do much, much better. And I think part of that's alignment, part of that's focus and attention. But part of that is that these guys are pros. You know, this is not something that we can't do in society and government. So I just feel like this is an area where we need lots of alignment. We need everyone to come to the table and say, you know, the words I like to use is, don't let me suggest something and you say no, and that takes this whole cycle. Tell me what I need to do to make sure that you're satisfied, and I'll do my best to do it. And so if we can sort of work the program in that manner, I think we'll be successful, and we'll again, I think Seattle is a city that has a lot of bridge needs, and in my view, I hope this can be an inflection point in doing these projects quickly and in a streamlined way. And if there were a project that you needed to do in a streamlined way, this is it. And I would say this is it in the United States right now. There's not one more important project in terms of speed in the U.S. than this project. And so I really feel that we need to use all of the skills that we have to deliver this project. That's what we should be about.
Sam, it looks like, according to our clock, you've got the last word here.
Sure. Sorry to time it that way. I think this has been a great discussion and great questions coming from the task force. And I think the same questions that we at SDOT are also very concerned about: the time, the permitting and clearance, the design, the funding. I think those are all things that we can answer as we move forward, or we can determine before it's too late that they are not answerable, and before we precluded any repair options if we're on this path of replacement. I also just want to, I heard some questions around, what would be the process for replacement. Even if we're on a repair pathway, we eventually will likely need to replace the bridge at some point in the future. And the opportunity we would have now is to have a really well-planned or a planned approach to that, rather than being back in an unplanned situation, which is where we could end up if we're on a repair pathway as well. So we're trying to do everything we can on the repair pathway to minimize the risk of that. But what Ted is bringing forward, and what a team behind him is thinking through, is just how we would do those things. So I will assure everybody here that if we are on this pathway of a replacement, before we take some of those steps that we can't walk back from, we would answer those very important questions. And I think the work that we've done to date on this bridge has been to make sure that we have all options available to us, and can continue to move forward on with every possibility at pretty rapid speed. To this point, we started strengthening the bridge very soon after we had to close it, and that has enabled us to have the level of choices that we still have available to us right now. So I think what the HNDB team has brought forward, and what we've been kicking the tires on to the point where we felt like it was something that the task force needed to hear, is just what you've heard so far, and what we think are some pretty creative ideas for how to move this project forward. So but I think everybody's questions are right on, and right where we've been as well as a department.
Sam, could you comment that the next step in the process, if the mayor were to pick replacement, would be a type, size, and location study? Could you remind us the questions that would answer that may have been brought up today by panel members?
Yeah, so the name of the study is what it is. It's the type of bridge, the size of it, and the location of it. And so in a lot of cases, we know a lot of what those are, but we would get a lot more detail on the preliminary engineering, and go from a conceptual idea that is, as Ted said, I think it's roughly the same square footage, or roughly two of these, but we would get a lot more detail on exactly that, and get to a level of preliminary engineering where you could have some more confidence in the cost estimates, and be able to go to those permitting agencies and say with a lot more assurance, here's exactly what this would take and what it would mean.
Funding agencies, yeah.
Mm-hmm. And funding agencies as well. So I think it's getting to that next level of design understanding, and really going through the details and being able to winnow down from a very conceptual level to something that's much more fixed. And frankly, at the end of a type, size, and location study, to have the ability, depending on the delivery technique that we use, to be very close to contract documents for construction, for a design build type of a construction, if we pursue that pathway.
Ted, on behalf of the task force, I want to thank you for joining us today, and also thank you and your team for the creative approach that you have presented to us today. I think it's incredibly intriguing, and hopefully proves out to be really addressing that time constraint that we are all concerned about. So thank you for your time today. Appreciate it.
Thank you for having me. Appreciate it.
So Heather, you're going to take us into the cost benefit analysis.